Do tubes have any practical use outside of tonal preference? That is what we'll talk about today. Okay, so today we are in the office and I just wanted to walk you through some design troubles I'm having at the moment. As you can see here, I have an ART audio preamp going into a Focusrite audio interface. Now this is different from the setup that I use mainly to do the other videos that you've seen on this channel, though I have my office set up now to where I can do some voiceovers for some animated videos. The problem I'm having is that the software that I use for these animated videos doesn't allow you to EQ your voice over the animations. Now, because of that, I thought, well, it might be a good idea to make an EQ for my setup here. As I can't do any post-production EQing, I'll have to do some pre-production EQing. But there's a slight problem with that. I'm using a phantom-powered mic, as it's a condenser mic. Because of that, it needs 48 volts at the input. That means I cannot put a preamp in front of the input of this ART audio preamp. I won't be able to do that unless I make the EQ with the capabilities of having its own phantom power. But then that starts to create a lot of redundancy, because then I have a phantom power unit here and I also have a phantom power unit in the Focusrite. So if I have to make a third phantom power unit just to get some EQ out of this, it just becomes kind of inefficient and redundant. So I had to cross that out of the list. I can't put a preamp in front of it because I want to use the phantom power that comes out of this amp. Now, I particularly wanted to make this video to show how tubes can actually be useful in certain scenarios aside from just tonal preference. So if I can't go on the input of this ART audio preamp, then the next logical choice is to try to use the output. Now keep in mind, I'm trying to make an active EQ, meaning that I'm either going to use op amps, transistors, or vacuum tubes. The easiest choice would be to use op amps. The second choice would be to use tubes, and I'll talk about why in a second. So the next logical option would be to use the output. But the problem with using the output is that then I have to construct a circuit that is able to withstand the output gain and voltage swing that comes out of this preamp, which is going to be high because obviously it's a preamp. That's its job. Its job is to amplify the signal that comes out of the condenser mic into the Focusrite. Now last night I did some measurements on this preamp, and this preamp will put out 17.5 volts peak to peak, which is about 6.5 volts RMS output. That's if I have all the dials turned up all the way, which right now I have them about 12 o'clock. Of course, in a typical scenario, I won't be turning up the dials all the way, though I wanted to see how much amplitude it could actually supply so I can see how much amplitude I want this EQ to withstand. Now, I could make an op amp active EQ that could withstand 17.5 volts at the input, though it would be kind of tricky as op amps aren't very friendly to having that high of an input. And I'll talk about why in a few. Because op amps are basically low voltage semiconductors with very tiny resistors or transistors, the headroom you have available tends to be very limited, especially given the voltage that you might operate them at. So your typical op amp will operate somewhere between 3 and 24 volts. This unit here, which likely has some op amps in it, operates off of a 9-volt adapter. Now, to follow suit with this, I was also going to try to make this unit powered by 9 volts. Though, as I said before, I can't do that if I want to use an op amp EQ and have enough headroom to withstand the output of this preamp. Because 9 volts isn't going to give me a 17 volt input. What does all that mean? That means that the EQ that I would design with a 9 volt adapter would likely distort and clip way before this thing would give me adequate input. It would be too sensitive. Again, it could work, but it would be sensitive and it wouldn't be as clean, and it would be prone to clipping and distortion. Now, I do have some options, however, related to the op amp before we go into the vacuum tube. And that would be to use a larger supply voltage. I could use a 24 volt supply, and that would likely solve the problem. Though, again, it gets much more complicated with using op amps if you want to drive them at such a high input level. Now, this is a situation where tubes actually become much more favorable. This is a perfect scenario in which to illustrate how vacuum tubes can actually help in engineering and actually have the advantage over semiconductors. Why is that? Well, because tubes are able to withstand much higher input voltages and are much less prone to distorting at much higher input voltages. So tubes are very good at voltage swing, and you've heard me say this before. Tubes are very good at processing voltages, whereas semiconductors like transistors, specifically power transistors, are very good at supplying current. Now, op amps are good at supplying gain. They're really good at taking really small signals and supplying gain in discrete electronics. But again, what we're doing here is a little overboard for your typical op amp setup, because the voltage that I'm going to have coming out of this preamp is so high. So the next logical step would be to use a tube. Use a 12AX7, because that would be able to withstand the voltages that I need, and then some. The only other complexity with that is that if I'm going to go as far as to make a tube amp, then I'm going to have to wire it at 120 volts input and use a transformer and operate it near around 120 to 200 volts. If I'm going to do that, I might as well just make a whole new microphone preamp unit instead of just making a active tube EQ. If I'm going to go as far as to make an active tube EQ, 3-band EQ, I might as well just make a whole new tube microphone preamp, which I do have set in my sights, though I was looking for something to do that wasn't as laborious, just to get me to the point to where I can make more of these videos. while still using this ART audio preamp. Now there is a third option. The tubes would work, though, as I said, I'm better off just making a whole new preamp if I'm going to do that. But there is a third option. The third and most reasonable option that would be the lowest in cost and would have the shortest turnover time would be to just make a passive 3-band EQ at the output of this ART audio preamp. The passive EQ would work great because, one, it doesn't need a power supply. All it is just some RC junctions, some resistor and capacitor junctions. Also, this amp makes enough gain to where it could drive that RC network without losing any voltage swing, substantial voltage swing. So this amp is strong enough to drive a RC circuit. And that would give me the ability to tune and tweak my voice to my preference as I make these animated videos. But going back to why op amps in this situation aren't as advantageous to use than tubes, what I want to do here is illustrate a little bit of that for you. And I'll get on my drawing board and we'll talk a little bit about op amps, tubes, and voltage swing. So one reason why it's so beneficial to use an op amp is because it has two inputs. If we recall, an op amp has both a positive and negative input. That helps us greatly in making a preamplifier or an active EQ for a microphone, because a microphone also has a plus and minus input, and there's also a ground. So it's really easy to make what's called a differential amplifier out of an op amp. But as I mentioned earlier, what becomes difficult is the fact that the op amp uses typically 3 to 24 volts. Though in this case, I was looking at using 9 volts initially because that's what my preamp is running off of. And I can either tap that same 9 volt adapter or get another 9 volt adapter and just make it all run on the same voltage. But again, what we're talking about is the limitations of that. So there's a limitation here because that 9 volts only gives us so much headroom. Another limitation of using this op amp is that if you see what I have here, op amps run their best when they have dual rails, what are called dual rails. Dual rails meaning that they need a positive voltage and a negative voltage to run. So that makes the power supply complexity increase. Though again, they're really good at making differential amplifiers as they have two inputs. So the input that I have coming from the microphone output, the microphone preamp output, could directly translate into the inputs of this op amp. Because we have to remember here, what I want here is unity gain. Now, unity gain means that I don't want any increase in gain in this circuit. I want that 17.5 volts peak to peak that can come out of this preamp to go straight into this opamp and then go into the EQ. That would be over here. The RC network for the EQ would be at the output of this opamp. But again, the troubles are that 9 volts only gives me so much headroom. Now again, I could put this up and say, okay, let's use a plus 24 volt and a minus 24 volt, and that would increase my headroom, and I probably could get away with that. But with an op amp, the input voltage that you're able to use will always be a little bit less than the supply voltage. So 24 volts is actually not too far away from 17. Though again, it would work, but there is still a likelihood of distortion. More so than if I did something a little bit cleaner, which would be using a vacuum tube. Now, symbol for a vacuum tube looks like this. This is your typical triode. A triode has 3 elements: a plate, a grid, and a cathode. We're just going to put a little resistor there to ground. That's your plate, this is your grid, and this is your cathode. The plate is typically the output, the grid is the input, and the cathode is ground. Now the cathode mixed with the plate resistor is where you get your gain factor from in a vacuum tube. But remember, well, we're not trying to get any gain out of this thing. We want unity gain. We just want something that's able to drive our EQ, which in this case would be here. Now, what makes a vacuum tube more friendly? Well, it's because vacuum tubes, like a 12AX7, which this could very well be, will run anywhere between 100 to 200 volts. That gives us a lot more headroom to run this 17.5 volt peak to peak voltage. So if I have my input signal coming in here, say this is my 17.5 volts, I want the output, which would come out here, to look the same. And the likelihood of this happening, especially with what's called a cathode follower, which is what we're looking at here, is a lot more dependable using a tube cathode follower than trying to use a differential amplifier or even a unity gain amplifier using an op amp. Cathode followers, tube cathode followers, are really good at taking the input signal here and making it translate without any alterations straight out at the output of this cathode without anything being changed. The op-amp, on the other hand, because of things I've mentioned like the limited voltage supply and also the transistors that we have in there, because we have to remember that an op-amp is nothing more than a smaller package of a transistor network. It's much harder to get these things to be friendly to higher voltages. So, where I have my 17 volt input, that's clean, there's more of a likelihood while I use this op-amp circuit that my signal looks something more like this, which, as you can see, it's starting to square. If you're familiar, anything that looks more like a square wave would be characterized as distortion. So if you see those flat tops, what we want are those crests. If we see the crest of the sine wave, you see here, you see here, we want these to be nice and smooth. We don't want them to start flattening out. That would indicate we'd have some distortion. And that distortion characteristic is much more likely to happen while using an op-amp at low voltage than using a tube at high voltage. So this gives us a practical illustration and circumstance in which using a tube would actually be more beneficial and advantageous in a circuit, regardless of the tonal quality that we're trying to achieve. So yes, even now, in the 21st century, in the year 2020, vacuum tubes still have a practical use and even have some advantages over semiconductor technology. Though, as I mentioned before, in this scenario, what would be even more advantageous than using the vacuum tube would be just to use a passive EQ network to get the attenuation I desire. Thanks for watching. I hope that helps in understanding the practical uses of a vacuum tube. Take care.